Previously in this course, we saw that a deadlock can occur rather easily when using async and await. To achieve a deadlock with the lock keyword, it's a little bit more complex. However, it can occur, and it's a good idea to understand why. The lock keyword will ensure that if the lock object is already locked, the thread is blocked until that lock object is unlocked. The reason a deadlock occurs is because two threads depend on accessing the same shared resource, but neither of them can, or they're simply waiting for each other indefinitely. To avoid deadlocks, we could try and follow a few simple principles. Each shared resource should have its own lock object. In the example we looked at earlier, this means the lock should only be used when working with the decimal variable total. If we were to introduce more parallel operations to access other shared resources, the best practice would be to introduce a separate lock object for that resource. This also means giving the lock object a more appropriate name, other than syncroot. For instance, you could call it total lock. But don't confuse that with something that totally locks the application. Also, according to the Microsoft guidelines, you should avoid using the following as a lock: a string, a type instance, which you get from a type of call, this, which is a reference to the current instance. This will help you avoid deadlocks when you have more than one shared resource. To give you an example of a deadlock, the most common situation is when you are using nested locks, and also requires more than one thread. This is for more advanced scenarios, but it's really not that uncommon. We'll first introduce two locks. The assumption here is that we have two shared resources that we'd like to work with. Now we want two operations to run in parallel. These will both use the two locks, which will eventually end up deadlocking both the operations. In the first operation, we're going to lock the first lock. Inside the locked context, we'll perform some operation. We can use thread.sleep with a very short sleep to simulate some work. At a glance, there's very minimum amount of work happening inside the locked context, meaning we're following the best practices that we've previously discussed. After that is completed, we'll go ahead and lock the second lock to interact with another shared resource. To keep it simple, let's just print something to the console. The first operation is now introduced, and simultaneously, we want to run another operation in parallel. This operation requires to first lock the second lock. Then, go ahead and run some operation, and again, we'll use thread.sleep to simulate this. After this is completed, we'll try and lock the first lock, and then print something to the console. Can you already spot why this is going to be a problem? If we just look through the code and what's happening here, we can see that the first operation, or thread, will lock the first object. The second operation, which will start almost at the same time, will lock the second lock object. When both of the first thread.sleeps are completed, they try to run the second piece of the code. But as the locks are already locked, they're going to wait until that's available. But given the fact that both of these threads are waiting for each other, that will never happen. This means both the threads will be blocked. And guess what? The locks are never going to be released because these operations can never complete. Hence, these parallel operations deadlocked. Let's just run this to confirm and we can use task.whenAll at the end of the method to just make sure that we await these operations. As you can see, it runs forever and doesn't print anything to the console. This proves our theory that this deadlocked. We know that the work they're both performing only takes about 2 milliseconds worth of work. So clearly, it should have been much quicker, and thus we have a deadlock. While this code shows how to introduce a deadlock, I'm pretty sure that most of us wouldn't intentionally write code like this. However, consider the case when you're consuming a library or calling a method from a locked context. You don't really know if that method internally uses a shared lock, which could then end up causing a deadlock. If you're using nested locks or even calling a method within your locked context, you should be very careful. In our code, one way of avoiding the deadlock would be to avoid sharing the same lock. In a real-world scenario, you'd have to be very cautious with how you use a lock, especially if you're introducing nested locks. Follow the guidelines and the best practices that we've discussed, and you should be able to avoid deadlocking your code. Next, we'll talk about canceling parallel operations.